Okay, review continuing page 3. So here we have a graph and we're asked questions about it. So the first one we're asked, is the degree of this odd or even? Okay, so remember, an even function will either look like this or like this on the endpoint. So here I have it going up on one end, down on the other. That means this has to be an odd function because an odd function will either do this or this, okay? And the leading coefficient has to be positive. I've got this leading coefficient has to be negative here. Let me backtrack on that. So the leading coefficient here has to be negative. So it looks like an inverted x cubed. So this is a negative leading coefficient. If it were positive, it would be this scenario where it goes up on the right and down on the left. Okay, what is the domain of this function? So look at the x-axis. As I travel from left to right, I'm getting all values from negative infinity to infinity. That's the domain of this function. If I look at the range, if I start at the bottom of the y-axis, I've got arrows pointing downward and then upward at the top of the y-axis. It looks like the range of this function is also negative infinity to infinity. Okay. Intervals where this function is increasing. Okay, so this function, I look at the x-axis, it appears this function is increasing from here to here, all the way over, here to here, and then it's increasing from here to here, and then it starts decreasing. So again, on the x-axis, it looks like I've got increase from, this is x equal -4 up to x equal -1, and then it looks like it decreases. So it starts out, the graph is decreasing. So it decreases up until it gets to, until it gets to -4. So that means it is increasing from -4. It increases all the way to the point -1. Then it starts to decrease. When it gets to 1, it increases again until it gets to, and that looks like 3.1 according to that graph. Okay, and then it starts to decrease. Okay, intervals where the function is decreasing. So you look at your graph, it is decreasing from negative infinity until you get to the point -4. Remember, I'm traveling on the x-axis. Then it starts to increase until I get to -1. Then it decreases between -1 and 1. Then it increases up to 3.1, and then it starts to decrease from 3.1 to infinity. Some people tend to write it decreases 3.1 to negative infinity, but you're traveling on the x-axis. You're not traveling on the y-axis here. So this is an x interval. So x values from 3.1 out to infinity, the graph goes down. So it is decreasing. Intervals where the function is strictly greater than 0. So that means where am I above the x-axis? So I'm above the axis here. It looks like here. And then everywhere else is below the axis. So where is it strictly above the axis? That interval would be from negative infinity to -5, parentheses. Next interval is from -2 to 1, -2 to 1. Next interval is from 1 to 3.1. And that's where it's strictly above the axis. Where is it less than or equal to 0? That means where is it below the axis or on the axis? That's this interval and then this interval out here. So that interval is from -5 with a bracket to -2, and then from 4 to infinity. Those are intervals where my graph is strictly below the y-axis. Where are the points where the function equals 0? That is, where are the roots? Where is it equal to 0 on the x-axis? So those points are at -5, 0. It looks like -2, 0, 1, 0, and 4, 0. Those are the x-intercepts. That's where y is equal to 0. Next question is any multiplicity. I can tell it crosses the axis at -5, -2, and 4, but it does not cross at 1. So it looks like I have a multiplicity of 2 at x equal 1, because I can tell that the graph does not cross the axis at that point. Is there an absolute minimum? So if you look at the graph goes down, so it's going to go to negative infinity. There is no absolute minimum. So there is no absolute minimum. Is there an absolute maximum? You look at this graph, there's an arrow pointing upward. It goes to infinity. So there is no absolute maximum. So every other max and min must be a relative max and min. So I look at it down here at -4,8, that's a relative min. So -4,8, that's a relative minimum. It looks like there is a relative maximum at -1, 1.6. So at -1, 1.6, that's a relative maximum. It looks like I've got a relative minimum at 1, 0. So relative minimum at 1, 0. And then it looks like a relative maximum at 3.1, 3.3. Okay, this is a long problem. There's not much computation, but it deals with decoding information. So the end behavior, the degree, the coefficient, and then things we've studied before, the domain, the range. Where is it increasing, decreasing? Where is it positive? Where is it negative? And then the thing we added this unit was the extrema. So absolute maximum, minimum, relative maximum, and minimum. So that is all for page 3. We'll come back and take a look at page 4 with our TI Inspire in just a moment.